In this video, we are going to talk about ANOVAs, the analysis of variance. So analysis of variance, this is another statistical test, a hypothesis test that comes up as very useful with a lot of business questions. We abbreviate this as ANOVA, that's what you'll typically hear me call it. And the purpose of an ANOVA, this is to see if there are differences in the means of more than two groups. So we went through the t-test, which is where we're just comparing two group means. Now we're going to cover the ANOVA, which is similar to a t-test, but you have more than two groups. Your independent variable, again, is nominal or categorical, but you're going to have at least three categories under that independent variable. Your dependent variable is quantitative. Technically, by the textbook, it should be interval or ratio, but you can work with ordinal data this way as well, as long as you just change it into numbers. The values that you get that you want to pay attention to, you're going to get an F test statistic and then the p-value. And you're also going to do a post-hoc test. You're going to pay attention to means and p-values from a post-hoc test, which we will talk about. ANOVAs can be similar to t-tests in that they can be independent or dependent, even though they're not exactly called that. Your dependent ANOVA is called a repeated measures ANOVA. So remember with the t-test, we talked about a dependent t-test would be done if you have one group of people and you have a time 1 measure and a time 2 measure. Well, let's say you have a time 3 measure on that same group of people, or maybe a time 4, time 5 measure. That is called a repeated measures ANOVA. We are not going to get into how to do a repeated measures ANOVA, but you could very easily search a YouTube video on how to do one, and it wouldn't be very difficult, especially once you know how to get through this type of ANOVA that we are covering. Assumptions here, just like t-tests, you need to have normal distribution of your outcome variable, that bell-shaped curve, and you need to have a large enough sample size. Make sure you have enough data, and typically the more data that you have, the better. Now, one thing to note, an ANOVA only tells you if there is a difference between any of the group means or not. It literally just tells you, yes, there's a difference. No, there is not. One of those answers. It doesn't give you any more information about which specific groups have significantly different means. So say you have 3 groups. Well, your ANOVA will just tell you that 2 of those means are significantly different. At least 2 of those means are significantly different. It doesn't tell you which 2. So it could be between group 1 and group 2, or it could be through group 1 and group 3, or group 2 and group 3, or all of them. The only way you can get more detailed information about which specific groups have unequal means is if you do a multiple comparison test, where you're just taking each pair of groups and looking at them, comparing them to see if they have significantly different means. The test that we're going to cover is what you covered in QBA 283. It's called Fisher's LSD, and we'll go through how to do that in Excel. So a few examples here of when you might use an ANOVA. Is there a significant difference in the average sales for salespeople who completed training program A, training program B, or no training program? In this case, you have 3 groups of employees who went through 3 different training programs. So this would be an independent ANOVA, if you want to call it that. And I will tell you, different textbooks call these ANOVAs different things. So it can get a little confusing, but you can always just Google. If you see the name of an ANOVA that you don't understand, just Google it. Of course, you can ask me as well. Are company-wide sales averages significantly different in the winter, spring, summer, or fall? So you're talking about a whole company, so one group of employees over 4 seasons. So that would be a repeated measures ANOVA. And is production significantly higher in the Louisiana plant, Mississippi plant, or Alabama plant? That would be your independent ANOVA. Okay, so how do you do an ANOVA in Excel? Now, let me tell you, the most complicated thing about doing an ANOVA is just cleaning the data, preparing the data to be run. So that's what I'm going to spend most of this video doing, is just rearranging our data. And then we'll go through these steps, we'll do an ANOVA, we'll talk about the results. So let's conduct an ANOVA to determine whether there is a difference in the variable communicates what is expected of me based on their function. So in our data set, we have communicates what is expected of me here, column D, and function. So that's what we're going to be interested in. And the first thing that you're going to want to do is sort function A to Z. Over here, you are going to take your different functions and give them each their own column. So finance, let's see, and you can use that little filter to see finance, HR, marketing, sales. So let's label each of those, marketing and sales. So now you're just going to go down here. So it communicates what is expected of me variable, column D. I'm going to highlight all the data under that for those in finance. Okay, and I'm going to paste it up here under the finance column. Then I'm going to grab the data for everyone that's in HR. And I'm going to paste it under the HR column. Then I'm going to grab the data for everyone in the next function, which is marketing. Paste it under marketing, and then finally sales. I can just change this to sort Z to A and grab it here. Now you might know of a faster way to do this, maybe using a VLOOKUP or something like that. Go for it. This is just kind of the simplest way to do it if you're not an expert with Excel. So this is how you need your data. You need labels at the top of each column and the data underneath. And they need to be side by side just like this. So then I'm going to go to data analysis. And I'm going to choose my ANOVA single factor, which is the very first one. Click OK. In the input range, I'm going to highlight the labels at the top down to the very last data set, or the very last data point. Since we did highlight the labels at the top, we're going to check labels in the first row and click OK. I would highly recommend pausing the video and going through all those steps to make sure you know how to do this. So here are our results. So let's go back to the PowerPoint because you should see the same thing on there. Okay, so in this first summary table, you're going to see the 4 groups, and you're going to see their sample sizes under count. You don't really need the sum. Their averages, these are the sample averages, and their variances. So we are testing, through the ANOVA, we are testing whether these sample averages are significantly different versus equal. Another way to think of it, if we had every person on earth that would ever possibly work in these 4 groups, would they have significantly different averages? That's what this ANOVA test is going to tell us. So then if we look down at the ANOVA section, a couple of values I want to direct your attention to. Where it says F, that is our F test statistic. And when you report all these numbers, just round 2 places past the decimal point. And we have our p-value under p-value. So as you can see, our p-value is more than 0.05. So there is not a difference between any of our averages. We're saying there's no significant difference between any of our averages. Now, normally, you would just stop there. You would not do a multiple comparison test because there are no differences. This ANOVA just told us there are no differences between any of the averages. So there's no need to do any further digging, right? But if you did find that there was a significant difference, so if your p-value was less than 0.05, then you would need to proceed and do the multiple comparison test to figure out where the differences lie. So we're going to proceed and we're going to do that multiple comparison test anyway, just to show you how to do it. So Fisher's LSD, this is straight from QBA 283 if you took my class. The hypotheses that we are testing here are null. You'll see in this yellowish box. The null is we're just looking to see are the two group means equal. The alternative is that the two group means are not equal. We're going to calculate a t-test statistic. So pay attention to this formula because we're about to type all this up in Excel. We have x bar, our sample average for the first group, minus the sample average for the second group, divided by, take the square root of the MSW, it's called the MSW, MS within in Excel. In parentheses, 1 divided by the sample size for the first group, plus 1 divided by the sample size for the second group. Now we're going to do this for every possible pair. So if we have 4 groups, we're going to have to list out all of the pairs of those 4 groups, every possible pair. And we're going to calculate a t-test statistic for each of those pairs. We are also going to get a p-value for each of those pairs. And you can use the function equals t.dist.2t. In parentheses, that test statistic that you just calculated, you're going to put there, but it does have to be the absolute value. So it needs to be a positive number. Comma, if you look in the Excel output, you'll see a df within. You're going to put that number there. And then if that p-value is less than alpha, that's telling you there is a significant difference, and vice versa. Okay, so let's go through this. I'm going to show you how to do this in Excel. It's not too terrible, but it's a couple of complicated formulas. So this is just my ANOVA output here. So that we already did that, our ANOVA output. This is how I like to set this up. Underneath the ANOVA output, I add 4 columns. A comparison column, a t-test stat column, a p-value column, and a conclusion column. Then under the comparison column, I list out every possible pair. Okay? So let's go ahead and pull up Excel, and I'm going to show you this. So comparisons, test stat, p-value, and conclusion. Under comparison, I'm just listing out all possible pairs of my groups. So finance, and it doesn't have to be pretty. Finance and HR, finance and marketing, finance and sales, HR and marketing, HR and sales, and marketing and sales. Okay, so next I am going to start typing out my t-test statistics. So that is kind of a complicated formula, so you might want to have that listed out, but let's look at this. We are taking, once again, the means of the 2 groups divided by the square root of the MSW plus 1 divided by the sample size, times 1 divided by the sample size plus 1 divided by the sample size of the other group. So let's just type that out. So equals, open parentheses, the average for finance is up here. I'm just going to click on it. Minus the average for HR. So again, this is finance and HR that we're doing. Close parentheses, divided by square root SQRT, open parentheses. The MSW, under MS alongside within, MSW. Asterisk, open parentheses twice. 1 divided by the sample size for the first group, which is right here under count. Close parentheses plus open parentheses. 1 divided by the sample size for the second group. Close parentheses, close parentheses, close parentheses. The last set of parentheses should be showing in a black color. Okay, So then what I'm going to do, just to show you a little trick to save a little bit of time, I'm going to make this stick because that's going to be the same number for all of these test stats. So I'm going to put in front of the D a $sign, and then in front of the 14 a $sign. And then I'm going to drag this down and just kind of tweak things a little bit. So for finance and marketing, I'm going to just switch this out. Finance was row 5, marketing was row 7. So this should be D5 minus D7, and these should be B5 minus B7. Then here, finance and sales. Finance is row 5, sales is row 8. So this should be D5 and D8. And then B5 and B8. HR and marketing. HR is row 6, marketing is row 7. So I'm going to change these. So hopefully you'll see what I'm doing. You can always, of course, type out the whole thing manually, but this should save you some time. And HR and sales, HR is row 6, sales is row 8. And then marketing sales, that's rows 7 and 8. Okay, so then the p-value, so like I showed you on the slide, it's t.dis.2t. So equals t.dis.2t. Now one trick, remember I told you the test statistic that you type in here has to be positive. A lot of these test statistics were negative, so I would use the absolute function, ABS, open parentheses, click on that, close parentheses, comma, and then it's the DF within, which was here, 689. Close parentheses and drag down. So then I am going to type up a conclusion column, which is an if statement. Now the first thing I want to mention, I don't know if you remember from QBA 283, but the alpha that you are going to use here needs to be 0.05 divided by the number of comparisons that you have, because every comparison that you do a test for, you have a 5% chance of error. So, if you're doing 6 comparisons, you have a 30% chance of error, and that's too high. So we are going to use 0.05 divided by 6 as alpha. So that's called Bonferroni's adjusted alpha. So it is 0.05 divided by 6. Our alpha is going to be 0.008333. So here, what I'm going to do equals if this is less than 0.008333, comma, I'm going to put sig diff for significant difference. If not, no sig diff. So that's telling us if the p-value is less than that alpha, there's a significant difference. If it's not, there's no significant difference. So since our ANOVA was insignificant, we obviously should get all insignificant t-test results from Fisher's LST. The last thing I wanted to show you for an ANOVA is simply how to write up the results on a technical report. So we would say something like, a single factor ANOVA was conducted to compare the ratings of managers across 4 different departments, list out the departments. There was not a significant effect of department on ratings at p is greater than 0.05 for the 4 groups. Then I'm going to put in parentheses F, in parentheses again, the 2 degrees of freedom that are listed here under DF, 3,689. equals. This is the F test statistic. So that 1.58 came from right here, 1.58. And then our p-value is greater than alpha, so I have p is greater than alpha. For a multiple comparisons test report, you're going to write something like post-hoc comparisons using Fisher's LSD multiple comparison test indicated blah, blah, blah. As you write out which groups were different or were not different, you are going to list those groups' means and standard deviations. So again, the means and standard deviations come from these averages. The standard deviation is the square root of these variances. So that's where those numbers come from. So if you're, ever writing this up for a project in my class or anything else, reach out to me if you have any questions, but you can use this as sort of a template for how to write up the results.